All right, seems to be recording. So um, I'll just get started. Thanks everybody for coming out and joining me to talk about 3D printing on a Saturday or whatever. I think it's Friday for some folks. I'll just start with a little background about myself. So as you see, my name is Troy Deck. I'm a mentor with C3D, and I'm also a professional software engineer. So I've been working in Silicon Valley tech companies like Google for 10 years. And I've been coding since I was 12. So I've always been really passionate about technology, interested in the ways that it can make people's lives better. And I've been 3D printing for several years. Over that time, seen that 3D printing has just gotten a lot easier. The printers have gotten a lot better. You get more for your money. And unfortunately, those benefits aren't very accessible to blind and visually impaired people because the software involved with 3D printing and the tools just weren't designed with screen readers or blind people in mind. But I believe it can be a great medium. I think, all of us here probably share that excitement about 3D printing. And so 3DMake is a free set of tools that I've been working on to kind of work around all those rough edges to give an accessible workflow for 3D printing. And basically 3DMake, it's a software tool that allows blind people to independently print and design 3D models. So who is this talk for? Basically, there are two audiences. One is blind and visually impaired people who are interested in doing 3D design or just printing 3D models on a printer that you have access to. And the other group is educators who are working with blind and visually impaired people who want to kind of foster more independence or get blind, students into creating their own models because that can be a kind of fun way to take 3D printing to the next level. So some notes on accessibility for this talk. This talk is intended to be accessible, although there are some visual aspects to it that I'm going to show for sighted people. I'm going to be describing all of the modeling. I'm going to be using a screen reader. Hopefully this pipes through to read out what's going on the screen for certain key parts where I'm demonstrating the software. And I also am going to send around right now a Google Doc that has basically all the code snippets that I'm going to write because I'm going to be demonstrating a little bit of how to use 3DMake to design a model with code. And so you can review those at your own pace later on. And, hopefully there'll be a recording that you can also watch if you want to understand what was going on there. So if there are any accessibility issues, obviously, like I said, we're a small group. So if something's not working or you need something explained in another way, please just, pop in there and interrupt me. And I'll try to, fix that issue because I do want this talk to be as accessible as possible. So in this talk, I'm going to explain a few different things. First, I'm going to talk about what 3DMake is, what it can do for you, sort of the high-level goals of 3DMake. Second, I'm going to talk about how to run it and just how to interact with it at a basic level, and I'm going to demonstrate that on my machine in Windows. Third, I'm going to talk about how to work with 3D models that you've downloaded that are made by other people. So a lot of us who are doing 3D printing, we get our start by working with models that are created by other people, and 3DMake supports that pretty well. Fourth is how to create your own 3D models non-visually. So that's going to be a basic demo of some concepts involved with OpenSCAD or OpenSCAD, which is, a way of designing 3D models. And then fifth is we're going to talk about the future of 3DMake, some things that I'd like to do, how the project is going, how I'm working on it, and how maybe you can contribute if you're interested. I'll also leave time for questions at the end. And I know this is being recorded, so I would love to invite people who are watching this as a recording later. If you have questions, send them to me. My email is troy@blindmakers.net. I'll probably try to repeat that a couple times. And if you email troy@blindmakers.net and you're doing a 3D printing project or you're having questions or comments about 3DMake, I'd love to hear that from you because I love to help people with their projects and I love to sort of just make 3DMake better. So love to be a part of the community in that way. If you do have a question, like I said earlier, since we're a small group, it's totally fine also to kind of wait for me to pause a little bit and just jump in there, because that's probably easier than holding it to the end. There's, of course, a lot of background about 3D printing, and I'm happy to provide people with additional resources. I can't go into everything. I can't even demonstrate all of the functions of 3DMake in an hour in a coherent way, so I'm just kind of sort of show the greatest hits. So, that being said, that's sort of the outline of the talk. Now let's move on to the goals of 3DMake and what it can do for you. 3DMake provides a non-visual way to do the things you need to do when you're 3D printing. So that means that, if you need to inspect models, if you need to orient a model so that it prints properly, if you need to slice models to prepare them for 3D printing and send the model to the printer, and also design your own models. Many of these processes in the past rely on sort of moving things around with a mouse and clicking things and looking at things on the screen. And so 3DMake provides a non-visual way to do all of those tasks. That's basically an overview of the goals of 3DMake. And now we're going to move on to a quick demo of how to run it. So in the doc that I sent around, the link that I sent around, there's a link to where you can download 3DMake. On my computer, I've already downloaded and installed it. So what I'm going to do is I'm going to share my screen, and then I'm going to show how you can interact with 3DMake. And I'm also going to use a screen reader too. So first, I'm going to share my screen. I have to request that.
Should be good now.
Okay, cool. So now I'm going to turn off my video because my head will get very close to the screen when I use it. I don't think I mentioned this in the beginning, but I'm visually impaired as well. So I just tend to sit really close to my computer. So now I'm going to hide this here a little bit, and we're going to talk about how to interact with 3DMake. So 3DMake is what's called a command line program, and many folks may not have used such a program before. The way that it works is that you type commands into the program. It's like sort of a text-based interaction, almost like a chatbot. So you'll type a command that you want it to run, and it'll do something. It'll produce some text that the screen reader can read in response. And in Windows, the way you interact with command line programs is you use something called command prompt or terminal. So if you hit the start button and you type in terminal and hit enter, you can open it. So now before I do that again, I'm actually going to open up NVDA, which is screen reader application, and just enable it. And let's see how it works here. NVDA. Okay, there we go. Are people able to hear the screen reader?
I was a little quiet, but I did hear it. Maybe like
okay. Yeah, let me turn up the volume. Oh, I don't know. Let's see if I can change the volume.
There's also a share sound option if you share your screen. That should make things come clearer.
Give me 1 second. So I don't know where this option is. I thought it was already sharing it. Oops. Screen share sound. There we go.
Yeah.
Thank you. Okay, so it was only hearing it through like my speakers being piped back in, I guess. Okay, so
speech mode beeps.
Can people hear that?
Speech mode talk.
That's better.
Okay, awesome. So now I'm going to open up
Search window.
the terminal.
Windows PowerShell. Windows PowerShell terminal PSC:\users\Troy Grader.
So this can be a little intimidating. The terminal is the Windows way of interacting with command line programs, and there are a lot of functions to it, but in order to use 3DMake, you don't really need to know that much about it. When I hit enter here, it will say something.
PSC:\users\Troy Grader.
So the PS is telling me I'm in something called PowerShell. Not important what that is. The next part is this C:\users\Troy. So this is your current folder. So when you're interacting with the terminal, you are in a particular directory, and this is just reminding you where you are. And then that little greater sign, it's just like a little separator between the directory and the command that you're going to type. So I have 3DMake installed on this machine already, and I can run 3DMake commands by using the 3DM program. So I type 3DM. Let me turn off my caps lock here. And then for a quick one, I'll run 3DM version. So just a little tip here. If you're using NVDA in the terminal, you're going to want to go and turn on reading more of the punctuation. That's important. And you're going to want to turn on the live updates mode. I think that's the NVDA key and then 5. So you want to make sure that it is reading live content, because when I run this program, it's going to say something and you want NVDA to read that out. So when I hit 3DM version, I hit enter.
3DMake version 0.4. Program location :
So I'm going to stop that, but it's basically just tells me that 3DMake is installed and what version it is. It also has more output that can be useful if you're like debugging something. There's another command that I want to highlight, 3DM help. And I'm not going to have it read everything here, but this will tell you all the different commands you can run and what they do.
Usage : 3DM actions. Left bracket options, right bracket. Left bracket input line file, right bracket. Examples : 3DM build organ slice, 3DM build organ slice dash model cover dash overlay supports, 3DM info alpaca.stl, 3DM preview alpaca.stl, 3D. So
those are examples of things that you might want to run, and I'll explain, commands that you run, so you don't have to understand this help here, but I just wanted to highlight that it's there. So now we are in C:\users /Troy, and I want to go into this folder that I created called 3DMake talk, and I'm going to explain one other command. This is not a 3DMake command, it's a terminal command, which is I want to change the directory. So I use the CD command. So if I type CD and then 3DMake talk,
PSC:\users /Troy /readmake line talk greater.
So now I'm in the 3DMake talk folder, and I can run 3DMem commands here. So the first thing I want to demonstrate is how to work with 3D models that you've downloaded. And so that's, this is just, we're done with the section of how to initially run 3DMake, and now we're going to talk about how to use its functions. Since we're a small group, I can actually just download, if somebody has a kind of model that they like or want to make a suggestion, I can just pull a model on the web and kind of demonstrate how you can use that. Anyone have anything in particular that they'd like to see? You can just search it up.
3DMake presentation. Selection removed. Out. Collapsed. New tab busy. List with one item button settings out of list. Link
You can also throw suggestions in the chat
meeting chat window
for any kind of model that you'd be interested in.
Benchy is pretty classic there. Oh, banana. Sure, Brian.
Okay, I see banana.
So
let's do a 3D model of a banana.
3D screen sharing meeting controls window.
This one's an object file. I don't want that. So how to find models is sort of beyond the scope of this presentation. And I know some of these websites have some, like, I would say, accessibility issues to them and special workarounds. But I definitely recommend folks check out the 3D printing accessibility mailing list, which basically explains more about how to. I'm having a hard time finding bananas. So let's do something different. Let's do, I don't know, Mount Everest.
Yeah.
Most of the banana models appear to be banana holders and things like that. Okay, I'm going to turn off the speech because it's irritating me. There we go. And I don't know. Here's a little topographical model of Everest. Now, if we're, not using this visually, we don't necessarily know what this model is shaped like. So, oops, sorry. I need more space on my screen here. I'm just going to download this model, and I'm going to save it into the folder that I was in here. Oh, wow. Okay, we're not going to download model today because it's taking too long. Instead, because I don't know how to tell. Oh, here we go. This is from Thingiverse. I know how to download models there. Let's see. We're going to go to the files section. It has a very large number of files. We're going to just download this one. So when you're working with 3D models, they're always usually in this standard file format called an STL file. And that's kind of like the lingua franca for 3D models. And that's what 3DMake uses and supports. So if we go in here, I'm going to copy the thing into my 3DMake talk folder. And sure why I didn't see. One moment, please. There we go. So now that it's in that folder, it'll be easy for me to access it from 3DM. So we're back in the terminal now, and I'm going to turn on the screen reader again.
Speech mode beeps. Speech mode talk.
And now I'm going to, so the file that I have is called everest.stl. The first feature that I want to demonstrate for 3DMake is its ability to describe a model to you using AI. And this is really useful because if you can't see the model preview and you want to get more information about the model, your only other option is to print it. That can take several hours. You know, those of us who do 3D printing know that that's kind of painful. And so if you want to select between a few different models that you've downloaded to find which one is the best, you can use the 3DM info command, which will describe the model to you. So we just do this by running 3DM info and then everest.stl. So if I hit enter, it will give me a description after a couple of seconds. Sometimes this can take a little bit longer, although I'm not sure in this case what's going on here.
Examining. Mesh size : x equals 175.24, y equals 135.31, z equals 41.17. Mesh center : x equals 87.62, y equals 67.65, z equals 20.58. A description : the model is a single, flat, rectangular slab with a complex, undulating surface texture resembling a mountainous terrain. The edges of the rectangle are straight and the overall shape is flat, like a raised relief map. There are several peaks and valleys across the surface, varying in height and steepness. Done. PSC:\users\troy\3DMake line talk grader. So
we're back into the regular command line here, and it gave a description of the model. So at first it tells you the size of the model in 3 dimensions, and I'll talk a little bit more about the coordinate system later. It also tells you the center of the model, and that can be useful for certain advanced operations that you might want to do. And then there's the AI description. And that description, I can say from being able to see the model, is very accurate. So it's this undulating surface that's on kind of cut to be a rectangle, and then on the top it undulates and has different peaks and valleys in it. So let's say that we like that model description, and now we want to print it. So in order to print a model, we can't directly print the STL file. We actually have to convert it to a format that our 3D printer understands. Now, when I set up 3DMake, or when you set up 3DMake on your machine, it will ask you which printer you want to choose. And so I already selected one, so it knows what kind of 3D printer I have. And by the way, it does support multiple 3D printers, but we're not going to talk about that in detail right now. So if I want to prepare the model for 3D printing, I run a process called slicing. Now, there are several free and open source programs for slicing, and none of them are accessible. So there's Prusa Slicer, Orca Slicer, Bamboo Slicer, Cura. None of them work well with the screen reader. And so a lot of folks tend to use Simplify 3D, but Simplify 3D costs money. 3DMake is a free alternative to this, and it uses the algorithms that are inside Prusa Slicer to do the advanced slicing, but it provides an accessible interaction with that. So if I want to slice this model, it's very simple. I just run 3DM, and then the slice command is called slice, and then everest.stl. So when I hit enter, it's going to tell me a little bit of stuff about, but not going to produce a lot of output, but it will produce a file, which is a G-code file. And that's the file that you can copy over to your printer.
Slicing.
So it's just slicing here. And sometimes this can take a little bit of time if you have a complex model. Since we have a terrain model, there's a lot of little peaks and valleys, and that takes the slicer program a little bit more time. When it's done, it's just going to tell us the file that it put the output into. And just let it run for a little bit. I'll also mention that slicing has a lot of options that you can tweak if you're kind of a power user. And those options are editable in 3DMake.
Estimated print time: 9 hours 1 minute 15 seconds. Filament use: about 45.65 meters. Result is everest.code. Done. PSC:\users\troy\3DMake line talk grader.
So you see, it also tells you the estimated print time and the amount of filament used. So this is a print that's going to take a lot of time. It'll be 9 hours. Now, you can't actually scale prints with 3DMake, and there's some description of that in the documentation, but there's like a scale option. So if I wanted to scale this down and print it at 50% size, that's pretty easy to do. Now, I wanted to describe one very common scenario with 3D printing, which is support material. So support material is something that you need to do sometimes when you have a print. So 3D printer, it builds up from the bottom in layers. And if you have a print where something sort of sticks out over thin air, if you try to extrude plastic over thin air, your print is going to fail because it's just not being supported. And so what the printer can do, or what the slicer can do, is add automatic support material. And basically the way that works is that it puts some plastic that's easy to break off underneath any part that's sticking out. So let's imagine that we have a model, for example, that's like an uppercase T. If it's standing up on the base of the T, then the arms that stick out are not going to have any support. And so if we print it, we need to add support material. So I'm going to demonstrate this because I actually have a T model. So it's called letterT.stl. So if I slice this, and this will be quicker, I promise. So if we do 3DM slice letterT.stl.
Slicing. Estimated print time, 37 minutes, 11 seconds. Filament use, about 2.10 meters. Result is...
So that says it's 37 minutes. Now, what we don't know from this is that it won't print properly without supports. So if you don't know about a model and its geometry, or if it doesn't say that it can be printed without supports, I recommend always using supports. And the way to do that is you do 3DM slice letterT.stl, and then you dash O space supports. So that enables this set of options that will turn on automatic supports. Now, if I run this.
Slicing. Estimated print time, 51 minutes, 16 seconds.
So sliced it. Now it takes 51 minutes. Why does it take longer? Because it has to extrude all of the plastic for the supports, and that takes extra time. But your print will actually succeed. And that's kind of the goal of 3D printing. So we want our print to succeed. Before it took 37 minutes, but it would fail. Now it takes 51 minutes, but it succeeds. However, if you think about it, when you just have this T-shaped model, you could actually turn it over and lie it flat on the print bed. Then you don't need supports for any of it. And 3DMake can do that automatically for you. So it can automatically orient the model in the best position so that even if it does need some support, it'll be the minimal amount of support. And you do that by using the 3DM orient command. Now, we combine commands together in 3DMake, and this is the first example of that. So if I do 3DM orient slice, it will automatically orient the model so that in this case it lies flat on the bed, and then it will slice it. And I'm going to do -O support so that even if it does need supports, it will automatically put them in there. So this is the version with the automatic supports, but after orienting it. And when I hit enter,
must either specify input file or run in a 3DMake project directory.
Sorry, I have to give an input file. So we have 3DM orient slice -O supports letterT.stl.
Must either specify input file or run in a 3DMake project directory. PSC:\users /read make line talk greater L.
Sorry, 1 second.
Space.
Let's do it here.
Must either specify input file or run in a 3DMake
I don't know why
project
I'm having an issue. Sorry.
PSC:\users /read. Speech mode on dash command. Speech mode off.
Interesting. So
speech mode beeps. Speech mode talk.
I think the issue here is that you have to put the -O supports at the very end of the line. So now I have this 3DM orient slice letterT.stl -O supports.
Auto dash orienting. Slicing. Estimated print time, 37 minutes, 13 seconds. Filament use, about 2.12 meters. Result is letter line T-oriented.code. Done.
So it might be hard
/users /read
to remember that. But this is 37 minutes. So this is, even when I've oriented it, when I print it with the necessary supports, which in this case is none, it only takes 37 minutes, which is the amount of time it took to print it upright in the position that would fail without supports. So by automatically orienting your print, you save yourself about 20 minutes of print time and maybe a meter or so of filament. So that automatic orientation is this advanced algorithm that is incorporated into 3DMake. I mean, it saves you the need. If you were doing this visually, often people would sort of manually rotate the part around with the mouse, and that's kind of difficult to do, but it's also tedious. The automatic orientation is a lot more convenient. So that was a brief view of how to inspect a model with 3DMake and how to convert the model so you can print it, and also how to orient it and add supports. Of course, all this is described in the 3DMake documentation, but I'd like to pause now and see if anyone has any questions about that, or wants to see anything else demonstrated before we move on to my demo of how to design your own model.
This is Caroline. I wanted to know, for the automatic orienting, what is the calculation it's doing? Is it trying to figure out the smallest print time, like the least amount of filament? Is it doing a bunch of different rotations and then calculating it and then picking the best one? How does it know?
Yeah, so it doesn't actually look at the print time. It looks at the unsupported area. So it's
Oh,
working, it's not incorporated with the slicer, but it's incorporated with the model. So if you think about a model, a little bit of detail about how automatic supports work in the slicer is that it looks for what we call overhangs that have a kind of shallow angle. So if you have an overhang that has an angle that is very gradual, then you can actually, the print can extrude plastic a little bit further out on each layer. But if it has to extrude a lot out, like 90 degrees, 80 degrees, 70 degrees, then that angle needs to be supported. And so the slicer will add automatic support. So what the orientation algorithm is doing is that it's trying to pick the rotation of the model in 3D space. Orientation and rotation are kind of the same thing. And it's trying to pick one that has the fewest sort of, I guess you could call them shallow or steep, but the fewest overhangs that would need additional support. And so
okay.
it's kind of calculating that in all the different orientations.
Thanks. Okay.
Yeah, and I do have to give credit to that orientation algorithm is from this piece of software called Tweaker 3, which I cannot remember the author's name, although it is in my credits. So they implemented that algorithm, and I just thought this is really useful. And so I put that in 3DMake. So yeah, any other questions about working with models that you've downloaded or about 3DMake in general? All right. Now I'm going to move on to demonstrating how you can create your own models non-visually. And this is a little bit of a complicated section, so I'll try to go slowly. What I'm going to show in this section is how to make a simple model, and it'll resemble a castle tower with a peaked roof. So imagine like a cylindrical tower with a conical roof and a little sort of arched doorway at the base that's curved. So I'm actually going to be using only cylinders in OpenSCAD or OpenSCAD to make this. So OpenSCAD or OpenSCAD, correct name is OpenSCAD, but I just find it hard to say that every time. So 3DMake uses this OpenSCAD, and it's a system for describing 3D models in text. So the way that works is that you have a file where you write instructions in text for how to create the model in this particular language. And you're basically building up a model from simple three-dimensional shapes. So you're adding them together or cutting them apart in order to describe a solid three-dimensional form. During this demonstration, I'm going to be coding up a model for the castle tower that I described before. And I'm going to be taking extra time to describe the shape of the model and showing how you can use 3DM info at each step of this to inspect it and see that it's kind of going the way you wanted. There's also going to be a visual preview for those of us who are sighted so that you can understand what's going on, but it's not necessary to have the visual preview. That's something that I'm just adding, for the presentation purpose. You can do all of this using 3DM info and by just having a description of it. I also have all of the steps of the code that I'm working on in the doc that I pasted in the chat before so that you can review them on your own later on. So in order to design our model, we need somewhere to put it first. And that means we need to create a 3DMake project. And a 3DMake project is nothing more than a directory or a folder with some files in it that 3DMake creates for you to hold different aspects of your design. And you can start an empty project with 3DM new. So you would just type 3DM new, hit enter, and then create a project name. For the purposes of this demo, I've already created an empty project that has just a very small amount of boilerplate code in it so that we can get started more quickly. So this project is in the folder that I have here called Castle Tower. I'm going to use the CD command
/users /troy
just
/3make
to
line
change
/
into
castle
that
tower greater.
folder. And now when I have a new project, there's we want to describe a model there, and we can open a text editor to edit that model using the 3DM edit-model command. So if we do edit-model, it will use the text editor that we've chosen, by default Notepad, but I'm using Notepad++ to edit the model file.
/users /troy /3make line /castle line tower /src /main.scad -notepad ++. Edit multi-line use less boss /shapes.scad.
So I'm just going to stop that there. But what it did here is open Notepad++, and it has a file in it. So now this file, to begin with, if you look in the documentation or the document that I shared, it has two BOSL. It has two commands that do a use, and use is basically just a way of including additional commands for us to work with. Those commands, not going to go into a lot of detail here, but the things that we're working with from this BOSL, they make our code a little bit easier to read and easier to understand. So now we have this blank file, and if we were to run 3DM build right now, it wouldn't produce anything because we have no models. The file just has these two use commands. They don't do anything. They just sort of set things up for us. So now what we're going to work on is describing the model. But before we do that, I'm actually going to take a little bit of a detour to explain the coordinate system that we use in OpenSCAD for the benefit of folks who haven't done this kind of modeling
Windows
before.
PowerShell row 1 3
So
Mount Everest 3D puzzle left paren.
we're going to open. So we're going to open this. So on the screen, I'm displaying a diagram here, and I'm going to go through it. In 3D printing, we use a three-dimensional coordinate system. It's like a grid coordinate system, and it's what we call Cartesian in mathematics, but it may be a little bit different than what you're used to in mathematics. So we have three axes, and they're perpendicular, and positions along those axes are described using a number. In OpenSCAD, this corresponds to a number of millimeters. So the first axis, the x-axis, is the left to right axis. So negative locations or numbers are on the left, and positive numbers are on the right. So right in the middle, we call that the origin. That's 0 for all three axes. And then x-axis is left to right. The y-axis, which is here on the screen as this sort of diagonal line, that's moving, as the numbers go up, it's moving away from you into the screen. And then, so negative numbers are kind of coming out of the screen towards you. And then the z-axis is probably the easiest to remember. It's up and down. So higher z value is, so like if z is 10, that's 10 millimeters above the ground. If z is 0, that's right on the ground, basically. So quick recap again, x is left to right, y is, toward you and then away from you, and then z is down and up. And these are important because when we are writing OpenSCAD code, we are describing the location of objects using numbers, using these coordinates. And we also describe the size of objects using numbers as well. So for example, if we had a rectangular object and we said that the x size is 10 and the y size is 10 and the z size is 50, then what we end up with is a sort of tall, skinny, tower kind of thing. It's a rectangular tower that's 5 centimeters high and 1 centimeter wide at the base. But if we said that the x is 50 and the y is 50 and the z is 10, then we have a sort of flat plate that's 1 centimeter high, and it's 5 centimeters wide and 5 centimeters long. So that's the coordinate system there. And again, these descriptions are in the doc if you want to refresh how the coordinates work. So now we're going to use that information a little bit to build up an object, the castle tower with the conical roof in OpenSCAD. So first of all, we want to create the body of the object. And the body of the object is going to be a cylinder. It's not just any cylinder. it needs to be in a particular orientation. It needs to be standing up on a flat end. So when we want to do that, we want that cylinder to be aligned with the z-axis because that's the axis that goes up and down. And so I'm going to use a z-sil command. So z-sil means a cylinder that's aligned with the z-axis. So I'm going to type z-sil in the file here, and then I'm going to do a left paren, and I'm going to give options for that command in the parentheses. So the first option I'm going to give is d equals 40, and that says the diameter of the cylinder. You can also use an R and give a radius. And then I'm going to say that I want it to be 60 millimeters high, so h equals 60. And I'm going to just close that. So this is example A. Now at the end, so now I'm going to read off this OpenSCAD command.
Speech mode beeps. Speech mode talk.
Using NVDA.
ZCYL left paren, D equals 40, H equals 60 right paren, semi, selected.
So you notice there's a semicolon at the end, and that's important. So in OpenSCAD, at the end of every shape that you're describing, you put a semicolon, and that tells it's the end of it. And that doesn't really make sense now, but when we are doing other modifications later, it'll become clear why we need that.
ZCYL left
so now,
D equals 40, H equals 60 right paren, semi, unselected.
I'm going to go into the terminal, and so first I have to save this. Then I'm going to go into the terminal and run 3DM build. So because we are in the project directory, I don't have to tell it what project I want to build. It knows that I want to build the Castle Tower project that I already opened with 3DM edit model. So if I go in here and I run 3DM build, the 3DM build will convert the description of the model that I wrote in OpenSCAD into an STL file.
Build time 0:00:00. Build time 0:00:00. Done. PSE /users /Troy /3DMake line talk /Castle line tower greater.
So it tells you the build time. The reason for that is sometimes if you have a complex model, it can take a while. And so if you're waiting for it, you want to know that it's still doing something. So it'll periodically update this timer so that you can check that it's still doing something. In this case, it was really quick. Now, what do we want to do? Well, first of all, we want to understand what does the model actually look like? I'm going to use 3DM info for this. So if I run 3DM info, I'm going to get an AI description and a size of the model. And remember that what we want is a cylinder standing up on its on its flat end, and we want it to be 60 millimeters high, 40 millimeters wide, and we also want it to look like a cylinder. So let's see what 3DM info says.
Examining. Mesh size : X equals 40.00, Y equals 39.78, Z equals 60.00. Mesh center : X equals 0.00, Y equals 0.00, Z equals 0.00. AI description : The model is a simple cylinder. It appears to be solid, not hollow. The sides of the cylinder are made of flat facets, giving it a slightly polygonal appearance rather than perfectly smooth. Done. PSE : /users /Troy /3DMake line talk /Castle line tower greater. So
now, for the benefit of sighted people in the audience, I'm going to just show what this actually looks like. Let me reload it here.
File collapse. Open control plus.
This little viewer.
STL file dialog file name : combo box ./ build /
Sorry about the noise here.
Speech mode on dash command. Speech mode off.
So what we have is a cylinder that is what the AI often calls faceted. So in 3D modeling, all of our models are not made of actually curved surfaces. They are made of a lot of flat surfaces. And if we have a flat surface every 10 degrees around the cylinder, for example, then you'll get ridges around the cylinder. It won't feel like a smooth cylinder. So there's a little trick that you can do in OpenSCAD to fix this. And I'm just going to add that to my file. It's like a little incantation that you can add. So if I go into this file, right now, the contents of this file are example A in the doc. That's the cylinder. And we want to make it example B, the smooth cylinder. So in order to do this, I just add two little lines, and I'm not going to explain them. You can just add them. So I'm going to add $FA equals 1, $FS equals 1. And then I have a semicolon after each of those. So if I have NVDA read this now. Oops.
Speech mode beeps. Speech mode talk. SS. $V equals 1 semi. $FS equals 1 semi. ZCYL left paren. D equals 40. H equals 60 right paren. Semi. Selected.
So if I save this, I can 3DM build it.
Windows PowerShell terminal PSE :
And I can actually I can build it and do the info in one command. So you can combine multiple commands together. So I'm going to do 3DM build info. When I hit enter, it'll build the new version, and then it'll tell me about it.
Building. Build time 0:00:00. Examining. Mesh size x equals 40.00, y equals 39.99, z equals 60.00. Mesh center x equals 0.00, y equals 0.00, z equals 0.00. And description the model is a simple, solid cylinder. It is taller than it is wide. The top and bottom are flat circular faces. The sides are smooth and curved. Done. PSE:\users\Troy\3DMake.
So and now it says it's smooth. It doesn't talk anything about facets. It doesn't talk anything about it being a low polygon model. So we solved that one problem. Now, I want to draw attention to one thing that you probably didn't notice, which is that the center of the mesh is 0, 0, 0. So we want our cylinder to be centered in the XY plane. That's like, the flat plane, but we don't want it to be halfway below the ground. By default, it will put it sort of center it on the Z axis as well, so that 33 centimeters of it will be below the plane and 3 centimeters will be above. And that's not what we want. Instead, oops, sorry about that. I'm going to edit this to add an additional argument or additional option to the zsil command. I'm going to add center equals false. So then it'll be d equals 40, h equals 60. Center equals false. And that tells it not to do the centering on the axis that the cylinder is aligned with. So don't center it on the Z axis. This might seem like a technicality. It's really important later because we're going to then put a cone on top of it and we want to know where to put the cone. So I'm not going to build this again because it won't look any different. It'll just be centered in a different place. So that's example B, the smooth cylinder. And now we're going to move to adding a cone to the top of this. And how do we make a cone? Well, it's probably going to surprise you to know that we use zsil again. So it's not really going to be a cylinder anymore, but we can use the same command. And the reason is that you can independently specify the diameter of the top and the bottom of the cylinder. So you can say that the bottom will be a wide, diameter and the top will be 0, and then it'll come to a point. It's not exactly a cylinder anymore, but it shows you the flexibility of this kind of command. So I'm going to type this zsil. And I'm going to make the bottom be 45 because I want the conical roof to kind of stick out a little bit. D equals 45, but I'm going to say D1 equals 45. So that means the diameter of the bottom. And then I'm going to say D2 equals 0. So it's going to come to a point. And then I'm going to set the height H equals 20. So that'll make a good looking roof. And I'm also going to do center equals false because remember, we don't want this centered on the origin. We want it to be lying flat. Now, you might notice that if I create this model, what's going to happen is that the cone is going to be at the bottom. It's going to be on the ground, and it's going to be kind of in the same place as the cylinder. And we want the cone to be on the top of the cylinder. And so what we need to do is put a additional command in front of it. So I'm just going to read the line that I just wrote, and then using, I'll read the contents of the thing, and then I'll update it.
Speech mode beeps. Speech mode talk. ZCYL left paren, D equals 40, H equals 60, center equals false right paren, semi, ZCYL left paren, D1 equals 45, D2 equals 0, H equals 20, center equals false right paren, semi, unselected, ZCYL left paren, D equals unselected. Oops.
So that's the whole thing. And I'm going to add before the second zsil is the cone. I want to move that up 60. So I'm going to type up 60. So up and then parentheses 60 tells me how far I want to move it up. And that's basically moving it up on the Z axis. You can also use the translate command and give it 3 things. So you could say translate 0 in the X, 0 in the Y, 60 in the Z. But I like this up, down, left, and right. These commands make it a lot easier for me to remember where things are. So when I do this, now I'm going to mention that I have up and then it's on the same line with the zsil and I have no semicolon. That's really important because we don't want to separate these things. We want the up to modify that zsil. The cone. Now, this semicolon would separate them apart. So that's the role of the semicolon in OpenSCAD. Now I'm going to save this and I'm going to do 3DM build info so that we can get a description of what it looks like. What we expect to see is a cone that's on top of a cylinder. And then I'm going to also show visually what it looks like.
Windows PowerShell. PSE:\\. Building. Build time 0:00:00. Build time 0:00:00. Build time 0:00:00. Build time 0:00:00. Examining. Mesh size x equals 45.00. Y equals 44.99. Z equals 80.00. Mesh center x equals 0.00. Y equals 0.00. Z equals 40.00. And description the model is a single part shaped like a cylinder with a cone on top. The cone's base is the same diameter as the cylinder, and it sits flush on the top surface of the cylinder. Done. PSE:.
So you notice it says it's a cylinder with a cone on top. That's good. I have no idea why it decided that the diameter of the cone is the same as the diameter of the cylinder, because it's actually not. But this is an example of sometimes the limitations in the AI model. So I'm always working on trying to improve its descriptions, but it sometimes gets things a little bit wrong. And that's just something that you have to know when you're trying to rely on it. Sometimes it misses little features like that. In fact, if we look at the visual preview, turn that off.
Speech mode off.
We look at the visual preview. Whoops, let me recenter this. There's a command to center it. View, viewpoint, center model. Sorry, it's taking a second. So I hit 3 here. You can see that this model and the visual preview is exactly what we wanted. We have a cone on top of a cylinder. And so it does look like a little tower with a roof. Now, this is the example D. Or sorry, no, that was the example C in the document that's attached for those who want to review the code later. Now what we're going to do is add a doorway to the bottom. And what we're going to do is add 2 doors. So we're going to basically cut through the base cylinder with a sort of borehole that is a semicircle. Now, of course, it's going to be kind of weird to have it just a semicircular doorway, but it's just the simplest thing that we can do. And so the way that we do this actually is we use a new kind of command, the difference command in OpenSCAD. So before, we've just been adding objects and it will combine them together. But you can also create a solid object and then use it to cut out of another object. So I could make a cylinder and then use that to cut a hole in another cylinder. And that's what I'm going to do. In this case, what we want is a cylinder that's flat on its side, like a log. And so if we want it flat on its side and we want it to go basically forward, then we want it to be aligned with the y-axis. So I'm going to use the y-cell command. Remember, we had z-cell before. And I am going to cut that out of the cylindrical tower at the base. So in order to do this, we're going to use the difference command, and I'll show how to do that. I'm going to type this first. And I'm going to have it read it out, and then I will explain what's going on here. So right now, we haven't actually cut anything. I'm just setting the stage, and I'm going to have this read it out.
Speech mode beeps. Speech mode talk. Unselected.
Oops.
Difference left paren, right paren, left brace CCYL left paren, D equals 40, H equals 60, center equals false right paren, semi, right brace up left paren, 60 right paren, ZCYL left paren, D1 equals 45, D2 equals 0, H equals 20, center equals false right paren, semi, selected. So
we've left alone the Z cell that corresponds to the cone. You know, it's just on its own line with the up thing here. But we have put the Z cell that corresponds to the vertical tower inside this difference. So we have a difference. It has no options in the parentheses, but it has these braces.
Speech mode off.
And these braces or curly brackets, they can contain more additional models. So some of the commands in OpenSCAD, in addition to taking options, they can take more additional models and they affect them. The up command works like that too. We could have actually put braces around what up command takes. But when we have multiple models, it's easier to use these braces or curly brackets. So the way the difference works is it takes the first solid object that's inside it, and then it subtracts out any later solid objects from that. Right now, there's nothing to subtract because I haven't created the sideways cylinder that it will cut out from the bottom. So I'm going to do that now. So we have difference, Z cell D equals 40, H equals 60, center equals false. And then underneath that, I'm going to add a new cylinder. And this cylinder is lying down. It's aligned with the y-axis, so I'm going to use Y cell. Now, I want this to have a diameter of 15. The height of it or length of it doesn't actually matter too much. We just need it to be wider than the cylinder that it's cutting out. We need it to be longer so that it goes beyond the edges so that it cuts all the way through. So I'm just going to say H equals 50 because the diameter is 40. And then now we come to the centering thing. Now you notice I've been centering equals false, but in this case, I actually want it to be centered so that it is cutting not only forward from the middle of the tower, but backwards. So we'll have 2 doorways and it'll go all the way through. So I'm just going to say center equals true. Now I'm going to build this and we're going to see what we get. So I'm going to save it, but first I'm going to read it off again.
Speech mode beeps. Speech mode talk. Difference left paren, right paren, left brace CCYL left paren, D equals 40, H equals 60, center equals false right paren, semi, YCYL left paren, D equals 15, H equals 50, center equals true right paren, semi, right brace up left paren, 60 right paren, ZCYL left paren, D1 equals 45, D2 equals 0, H equals 20, center equals false right paren, semi, selected. Difference left paren, right
Okay.
paren. Speech mode on dash command.
So
Speech mode off.
This is example D. And by the way, I know we're a little bit beyond time here. So I will just kind of speak through the next one, and I'm not going to have it read out, but I'm going to do a 3DM info build, and I'm going to demonstrate this. So here we go.
Speech mode talk.
3DM build info.
Building. Build time 0:00:00:00. 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 Build time 0:00:00:00.
Here we go. I'll just make it read it out for us.
Selected. Space selected. F its side. Near the bottom. The cone sits directly on top of a cylinder and shares the same diameter. Done. Selected. O selected.
Oh, I see. We have to actually, I think we forgot to save this.
Build it again. Windows PowerShell. PS:// Building. Build time 0:00:00:00. Build time 0:00:00:00. Build time 0:00:00:00.
Figure out why
Build time 0:00:00:00. Build time 0:00:00:00. Build time 0:00:00:00. Examining. Mesh size : x equals 45.00. Y equals 44.99. Z equals 80.00. Mesh center : x equals 0.00. Y equals 0.00. Z equals 40.00. AI description : the model is a single part shaped like a cylinder with conical C:/users screen sharing meeting controls.
Here, I'll have it read this.
Windows PowerShell. Windows PowerShell terminal selected. Selected. Dot selected. Cutout selected. The model is a single part shaped like a cylinder with a conical top. At the bottom of the cylinder is a small semicircular notch or
Okay, so it has a semicircular notch, and then if we do the
screen sharing meeting,
we look at this, then it has like a sort of semicircle board through the bottom of it. Now I'm just going to make one more change, which is it looks kind of weird to have a doorway that's as wide as it is high and is like a semicircle, right? It's a really wide, short thing. And what we want is to make that taller. What we can do is before we use the cylinder to cut through this vertical tower, we can scale it and stretch it in the vertical dimension. And we do this using the Z-scale command. So we want to scale it in the vertical direction, which is the Z direction. And we just add a Z-scale on the line before the Y sill that we're cutting out. So we're going to scale it by a factor of 2. It's going to be twice as high. I'm just going to save that. And this is, again, example E in the doc. And then I'm going to build it, and I will read out the description. It's pretty much the same description because it will just say that there's a semicircle notch. The notch is actually, this description is a little odd because it's not correct. But if we look at the cylinder, the tower, we can see now that we have a taller arched doorway. So now we end up with a tower with a cone on the top. We've got a cylinder, and then we have an arched doorway in the bottom. Now, I know there was a lot to process there. Hopefully, folks who are interested in doing OpenSCAD modeling can review those descriptions, but I'd also like to create more OpenSCAD tutorials on YouTube and sort of explain how to do this non-visually in the future. Now, before we move on, I'll just mention that we're not limited to using cylinders. So we could have a square doorway cut out. There's all kinds of different shapes that you can create. And there are even OpenSCAD tools for creating really complex and cool shapes. You can create snowflakes, you can create terrain in OpenSCAD. It just becomes more advanced, or a matter of finding libraries where people have already created those shapes and then incorporating it into your own code. So it's very easy to kind of share shapes with OpenSCAD and to build on top of other people's work. Okay, I want to briefly talk about the future of 3DMake. And 3DMake is, as we know, it's a free tool, and I'm just working on it on my own. So there's a lot of things that would make it better, make it easier to use, make the IAI better, that I'm just still working on. And I'm sort of committed to hoping to build a community around 3DMake. It's kind of a labor of love that I'm always trying to improve. If you want to help with it in any way, if you have programming skills, or you just have the ability to try it out and give feedback, let me know what's not working, give suggestions, I'd love to hear it. You can always email me at troy@blindmakers.net. There are only a few printers that are currently supported in 3DMake, but it's very easy for me to add more printers. I'm just doing it as people ask for them. So if you run it and you don't see your printer supported, you can just tell me and I will make that work. And I just want to plug a couple things. One is where you can get 3DMake, which is you can follow the link in the doc that I pasted in there. It's on GitHub, github.com/tdeck/3dmake. I also have a website, blindmakers.net, where I write about, I have a little blog, and I also have a lot of links to different resources for specifically for people who are blind and visually impaired doing 3D printing, doing electronics, and other kind of cool maker hobbies that I'm into. And of course, again, you can reach me, like I said multiple times, at troy@blindmakers.net. Always encourage people to reach out to me. I also want to thank other folks who have been helping with this project. I want to thank Caroline for setting up this talk and organizing it. I also want to thank Ka for providing feedback on 3D Make and trying it out. And also Edis Adilovich and Tom Babinski have also been giving good feedback and using 3D Make for 3D modeling. And I've really benefited from their suggestions and advice. So that's all I wanted to present today. If folks have any questions, I'd love to answer them. And thanks for watching my talk.
Thank you, Troy. I'm really excited to see where this is going to go. 3D Make would have solved, I think, a lot of problems when I was running the 3D printing club at the Ohio State School for the Blind, just especially with the previews here and being able to know what your design as you go. So
Yeah,
I'm
definitely.
really excited for this.
And there's still some challenges with the AI part. It still makes mistakes in describing things, which is tough, right? I think it's still better than nothing. But like that's an actively evolving area that it's kind of interesting. I mean, I think we're all kind of learning to figure out what AI is good at and what it's not good at. But definitely, like this is way faster than, let's say, printing your model and feeling. And I'm also working on, some other kind of intermediate options between the AI description and printing the whole model. For example, I'd love to create like embosser output. So folks who have an embosser can have a sort of 2D preview of the model. Right now, 3D Make can generate these sort of silhouette previews, which are just like an outline of the model, but you can print them very quickly on your print bed and then feel them. They don't give you all the information, obviously, but they're very quick and you can get a sense of sort of the shape of the model. I'd like to also extend that functionality further, and I have some ideas that I've been working on there with sort of tactile previews, because I think at the end of the day, like text is kind of limited for describing, objects. And sometimes you really want to know like what is the actual spatial relationship.
And I want to know too, for the AI part, can you ask a follow-up question?
Yes, good question. I forgot to demo this, or actually I didn't include it in the demo, but if you run, like I can demo this real quick. Let me share my screen.
Sure.
So there's an interactive mode. Turn on NVDA again to see.
Speech mode beeps. Speech mode talk.
So let's do the Everest model. So I'll go back in here. 3DM info, and then everest.stl, and then I can do -- interactive. So if I do that, the 2 dashes and then interactive, that's what we call an option. And that will enable it to, instead of just running and exiting, it'll leave a little prompt open where I can like ask follow-up questions. So I'm going to do it now. Now, while it's doing the description, I'll mention that there's something interesting with the AI models, which is that you
Examining. Mesh size : x equals 175.24, y equals 135.31, z equals 41.17. Mesh center : x equals 87.62, y equals 67.65, z equals 20.58. AI description : the model appears to be a rectangular slab with a complex, mountainous terrain on its upper surface. The terrain includes multiple peaks and valleys of varying heights and depths, creating a rugged, uneven landscape. The bottom surface of the slab is flat. You are in interactive mode and can ask the AI follow - up questions. To stop asking questions, type quote, stop quote, quote, quick quote, or quote, exit :
Yeah. So I just noticed a typo here, but so I can keep asking it questions and have a dialogue with it. And then when I want to stop, I can type quit or exit or stop. Basically, I didn't want you to have to remember one specific thing. So I can say like, how many peaks are there?
Yeah.
And one thing I will mention with this simple question is AIs are extremely bad at counting things in the image. That's something I've noticed, but we'll see what it says. See if it's right. It's kind of fun.
It's difficult to define a quote peak quote precisely in such a complex terrain. There are several hot points, but whether they qualify as distinct peaks or are just shoulders of larger formations is subjective. There are at least 3 prominent high areas, but many more smaller rises and bumps could be considered peaks depending on how you define them.
Interesting little lawyer answer, but I guess that's good. You can tell that it's a very complex
Yeah,
term.
asking accounting is a bad idea, I guess, for the.
Yeah. Does it, we could say like,
But
does it,
I curious that could you change the model at the background you are using the AI model? Could you change it, or it's is there
um,
any way for changing the AI model?
I
Something
think
like instead
right
of.
now
Mhm.
it's hard coded in. So, because I figured people like, I don't want to give people too many configuration things because it'll be hard. I
Yeah.
believe that what it's now using is Gemini. So
Mhm.
when you sign up, you need to like create an API key. It's set up. It's not too hard. But it's using the Gemini Pro model. The reason is
Mhm.
because it does a pretty good job and it's free. And I didn't want people to have to pay for something.
Mhm.
I experimented with a few different Gemini models and I experimented with a lot with prompts. So if you're interested in helping with this, since I know that you're a software engineer, I have
Yeah.
a thing on GitHub, which is called the 3DMake Prompt Experimenter. And it's like my little framework for trying new prompts. So I have a bunch of different prompts in there, and then it'll run like a bunch of test models through them. And then I, compare, which prompts are producing a better output. So that system was designed to allow you to change models, to change prompts and stuff. But once I put it into 3DMake, I simplified it. So I do have a way of sort of uh, gradually improving on the AI output. But I just it's not super easy to tweak it within 3DMake itself. I did have an idea of like putting the prompt in a text file so you could edit it. But I also think, I'm not sure how many people in the target user group would want to be playing around with the prompt all the time. I would love to make it just the default one better. Another thing that we can do for this, by the way, since you mentioned counting, sometimes you get a 3D STL file that has multiple different pieces in it, right? Like they're all laid out to print. And in that case, the model sometimes tries to count those objects and does it wrong. So something I could do is run an algorithm to count the objects in the file and then like provide that count to the model as part of the prompt. So that's something that I was thinking of doing. So there's different ideas for how to make the AI part better, but it's sort of it's an interesting multifaceted problem. In terms of playing with different models, I haven't done that much mainly because um, I'm constrained by what would be easy for people to set up. So there's also what they call local models that run locally on your machine, and those are great because they're free. But the downside is that they take like 12 gigabytes of space. So I thought no one's going to want to, install this 12 gigabyte local model.
Yeah.
So, it's interesting. I've been learning a lot about just kind of the pros and cons. And I also have a friend who works on like multimodal like model prompt engineering at Google. So I've been asking him for like different tips about how to make it better. And that's how I know that they're always bad at counting things and it's not just me. Like he's like, yeah, they're just always bad at counting things. I guess I should give him credit too. His name's Chenille Dodia, and he's been very helpful, just like giving me advice.
I don't know. Is there a way that, like, let's say we're printing a bunch of towers, okay, like duplicating, I want five of the exact same tower, multiply or being able to select one, print one small and one big, or is this really just for doing one model at a time right now?
Right now, it only does one model at a time, but I definitely have it on my roadmap to um, be able to do multiple models. For one thing, uh, you can actually create multiple models in a project, but you can only slice them one at a time now. So I would like,
Hmm.
I think that that's like not too far in the future where I could
Hmm.
support creating a whole plate of multiple models. Multiplying, I hadn't actually thought of for some reason, but that's actually a great suggestion. I'm going to add that to my Trello board.
Yeah, because I think sometimes we just want to print a bunch of tiny things, like five at once, right?
Yeah,
Not
exactly. And I
one
think it's
little
not
thing at
too
a time.
hard to have it do that. Now, where it might get a little complicated is what's a good interface for specifying I want five of this one and three of this one and stuff. But I think we can build that up as we go along. Multiplying, that's a great feature. I would love to add
Hmm.
that.
I think even just multiplying to start is, if you're not making them different, just some multiple is better than nothing.
Yeah, absolutely. And that's totally I'm sure that that's pretty doable.
Yeah.
It's just a matter of piping it through. So, other things that I could add. So right now, there's no way to manually rotate the object if you wanted to. Um, that's something that I think is a little bit hard to figure out how
Mm.
to do it right, but like it's not difficult to just say, to pipe something through. I just haven't added it. So there's a lot of little features like that. Another thing that I haven't mentioned, this is an advanced feature, but it's super, super useful, is that so in OpenSCAD, you can create functions in what's called a library that other people can use. So for example, I created a Braille one that allows you to add Braille. There's the one that I was using today that has like the Z sill and the Y sill, and it has all kinds of cool shapes specific for 3D printing, like a teardrop hole for printing, holes in an upright orientation, all kinds of things.
Mm.
And 3DMake is the only system, I will say, that makes it easy to use OpenSCAD libraries, because the way to use it with the normal OpenSCAD is like you find some obscure folder on your computer, then you find a zip file of the library, then you download it, then you like copy it into this folder. In 3DMake, you just add the library name. So there's like a set of maybe like 6 or so libraries that it supports right now, but can add more if people find more ones that are good. You just add the library name to this config file, and then it's going to be available in your project. And so that makes it really, really easy to reuse code and to build, like, without having to copy and paste and without having to do this like complicated install process. So that's something that I built in there that
Yeah.
like I just wanted to have that, because even if you're a sighted person using the regular OpenSCAD tooling, working with libraries is really annoying and it doesn't work very well. And they add a lot once you learn to use the libraries, they add a lot to your experience. So I've been using them a lot.
I also just thought for your use case with being able to manually rotate models,
Yeah.
where that might come into play is when you have Braille on models and you want the Braille to be vertical, even if the overall shape, I don't know, that needs more supports now. That's not optimal, but you want your Braille vertical.
Yeah. So the way
Even
this
that's where
works,
like that would help.
so there is a workaround, which is you can always rotate objects in OpenSCAD. So I didn't demonstrate rotation, but there's a command for
Oh,
rotating an object in 3 axes. Um, and so, for example, like I think I might have one
Screen
online
sharing.
somewhere.
3D
Let's
make
see.
present. 3D speech mode on dash command.
Um,
Speech mode off.
so I think I have like some cool little. I think I might have some examples of. 1 second here. There's a library I created for doing Braille, and it's called Braille Cares. And basically, it natively supports doing like Braille on the side of a model or lying flat, because Braille on the side of the model feels way nicer, but
hmm.
sometimes you have to have it lying flat,
Yeah.
right? And so I'll just read this out. But if you're using 3DMake, you just say, I want to use this Braille Cares library, and then you do use Braille Cares -ueb.scad. So this right now it supports just UEB, like English Braille, but I wanted to add other languages. And then you do this Braille label command, where you tell it, you have like a list here of each character that you want to put in here. And the reason you do this is because you can also put contractions so that correspond to one
Mm.
character cell. So this will make an upright Braille thing, because by default, it'll make Braille on a plate, basically a flat plate that's upright. And by default, that's the better option if you're just doing an independent label. But sometimes you need it flat, so you can also say, oh, I want to change the plate thickness, or I want to lie it flat. But there is also the option recently I was doing a project where I wanted Braille on a flat base, but I wanted it to be nicer and more readable. It tends to be, for those who don't know, kind of scratchy when you print it
Hmm.
bumps like right on top of an object. And the reason is because the print head that's extruding plastic, it has to keep like lifting off. And so it's kind of like when you get an ice cream cone from the ice cream machine, there's a little tip at the top. Like it gets these little tips at each little bump, and it's not great.
Oh.
But I found is that if I rotate it 30 degrees up, and then like create a little triangular base for it, that I get like a much nicer feeling thing, but it can be sort of on the top side of something rather than, having to hold your finger vertically to try to read it. So yeah, this library, super useful. I know I'm not sort of reading out how to use this, but I'm going to copy the documentation right into the chat. And so that way people can take
And
a
I'll put
look.
in the notes for
Let's
this
see.
too.
Yeah. Okay, chat. Yeah, so that Braille Cares library. So if you want to use libraries in 3DMake, it's described in the README of 3DMake, and you can list the available libraries using 3DM space list libraries, and then the README will explain how to incorporate them into your projects. But there's some pretty cool ones for mathematical modeling, for like rounding off objects, like if you want to fillet objects, which is common in 3D modeling. You can take an object and round it off with this library called Round Anything. And there's the Braille one, which, I included because it's a common thing that I want to do with models. Any other questions or thoughts?
Where do you need help next? Like what type of people do you need to know? Like I know people can email you, but where do you need the most support to
Yes,
keep going
I
here?
just about to ask that question. Is there any roadmap? And I couldn't see on the GitHub profile.
Yeah,
Uh,
good question. So because I
there is
haven't had
no,
anyone who's a software
yeah.
developer reach out to me and ask to help with it, I don't have like a public roadmap. But I do have like a Trello board. So, if
Yeah.
you want to help with the software part, I can publish that. In terms of what I'm looking for now. So first of all, I'm really trying to prioritize, blind folks who want to use this for obvious reasons. And so that's part of the reason why it doesn't have like a visual preview of the models, because I feel like if I were using that, then, I would just use that. And then I would, I wouldn't make the AI descriptions better. In terms of like, if you have time to do software, to help with the software part of it, definitely you have my email, Haidar. I'll send you the info there about what I'm trying to do. I have a long list of different things that I'd want to do. And because I'm just working on it myself, I kind of prioritize by things that are blocking like actual users. Like if there's someone who's actually using this for modeling things, there's like maybe 3 people that I know who've done this. Like if they want something, I try to prioritize it, right? Because it's sort of the early stages. B, things that I'd like to add, for example, is mesh repair. And there's like a kind of detailed reason for that, but in OpenSCAD, you can import an STL file and then modify it more with OpenSCAD. And so, but it doesn't work well with meshes that have any little issue with them. So I want to make like a mesh repair thing. But also I'd like to make the AI stuff better. I'd like to make slicing settings easier to edit. I'd like to add the what I'm calling the relief previews, which is, I can explain that in more detail maybe another time, but that's kind of a more complex kind of tactile preview that prints quickly. I'd like to add support for like embosser, like, export or exporting SVGs. And of course, adding more libraries, adding more printers. And then the big one is figuring out how to get it to upload stuff to Bamboo printers, which is painful because Bamboo Labs is making it painful. But it's kind of like a feature that a lot of people want because a lot of people have those printers. So that's something I'd like to do too. And yeah, so I'm really like, more people using this. Also, another thing that is a huge help that I forgot to mention, but like writing documentation. Like I spend a lot of time trying to make the documentation better, and I'm trying to create videos that explain how to use this and have like a screen reader so that a blind person will get a preview of what the interaction actually looks like. And those take me a while to prepare. So, I'm trying to do them, but more people using it and writing about their experience and documenting things is also like extremely helpful. I think the documentation is just as important as software, and like having tutorials and having things that introduce concepts to people.
Yeah.
I love
Also,
hearing that action
developer
plan.
documentation will be really perfect.
Oh, sorry, could you repeat that?
Yeah.
Yeah, developer documentation also will be perfect. How for the maintainers, for the contributors,
Yeah,
that will be really
exactly.
perfect contributor and the on the library that will be perfect.
I mean, I'm going to write that the moment that someone's interested in actually contributing to the software, but
Sure,
I'm
sure.
not going to spend time doing it before that. So if
I
you have
just
time,
I just cloned the repo, by the way. I will check the
nice.
LLM part. Yeah.
So yeah, I will write some. I tried to structure it pretty reasonably. So it's a Python program, and then within it, it embeds there's like, it uses Purchase Slicer, the binary, and OpenSCAD, the binary. And I distribute it. I can talk a little bit about the developer stuff, but yeah, I think throwing together some, at least a contributing file would be smart too. And yeah, I'd love to connect with you another time about this, and see what your thoughts are. It has a little bit. I tried to arrange it so that the commands are like independent, and like you can edit one thing without editing other things. But it also has no automated tests right now because I just haven't had time to do that stuff. Like if it's only one person working on it, then it's easy for me to update it and test it manually. But that's something that I would like to add too. Yeah. Well, thanks for taking a look. I think I'm happy to connect with people offline, but I know that we're like half an hour beyond the end, so I want folks to be able to get to whatever they need to get to next.
Troy, this is Susan with C3D. I just wanted to just reiterate that feel free to put information on our Slack. If you want to post it, I know you've done that already. You might put something out there. It might be quiet, but I mean, there might be sometimes someone might just, jump on and give you some, be interested in helping. Because I was looking at our list, we do have some computer software people that I thought I might try and message again to tell them to take a look.
Yeah, thanks for bringing that up. I guess what I'll do is add some documentation for developers, and then I'll do that because I agree. I feel like I naturally don't self-promote or don't promote this stuff as much as some people tell me I should. I was also thinking of creating a mailing list, to so that people can know, because I'm always making updates, like new versions and new features, and I think people who are using it will want to know about those features so they can get them. So something like that would probably be useful. Like I've been releasing like almost basically every 2 weeks, every 2 to 2.5 weeks. And usually there's like big improvements, like the whole thing with the libraries and being able to install them. That was like in the latest version. And so I'm hoping that, this will just continue to get better and better. And obviously having more people work on developing it and fixing bugs and stuff would be a huge improvement too.
Yeah, our 3D making a 3D accessible printing thread would be, I think that's where you've put it, but I just wanted to say that again. Thank you.
No, thank you very much. It's a really good reminder that there's probably folks in there who could have something to contribute. All right. Well, thanks everybody coming to this presentation. I know it ran a bit longer. I swear I did practice how long it would take, but you know how things are when you present them. They take a little longer than you expect. And I really appreciate everybody's interest and suggestions. And Haidar, I will definitely at least add some basic developer documentation, and I will communicate with you offline about that. All right.
Thank you very much. Also, I will check it. I cloned the repository, okay, in a couple of days at some nights, if I can find a chance. So I will check to install it, and maybe I can create a documentation even for you.
Yeah, that would be good. I mean, I think when you first try to do something, you find all of the like stuff that was not intuitive that I might not realize. So, having a newcomer like
a pull request, maybe first pull request comes from me, I guess, for this repository. Let's check it.
I would totally celebrate a first pull request.
Yeah, thank you very much. I really like the idea, and I didn't use the OpenSCAD before, but maybe I can jump a little bit to learn after your presentation. And also I like the idea of this project. I hope it will get more developer to help you in here.
Yeah, and one thing I didn't even mention is that eventually I'd like to add like a graphical interface to it too, so it doesn't have to be like a command line program forever. There's certain advantages to doing it the way that I've done it, but there's like sort of whatever kind of makes it easier to use for people. In the end, it's available to sort of be adapted. Wow. All right, I'm going to say goodbye. Thanks everybody for coming out, and I hope you have a great weekend.